Right, so we're back with the space probe question. So you've got this space probe moving to the right at 160 meters per second, and then there's an explosion that fires a capsule out, and the probe moves at a higher velocity now to the right, and the capsule we worked out before moves to the left with a velocity of 27 meters per second. Okay, so we worked that out in a previous video using the principle of conservation of momentum. Now, we're going to look at the kinetic energy before and after the explosion now, okay? So the kinetic energy before, all right? So we know that that's going to be equal to half mv squared. So that's going to be half times 500 times 160 squared. So that's the initial kinetic energy, and it comes out as 6.4 times 10 to the 6 joules. So that's your kinetic energy before the explosion. Now afterwards, maybe I should have put a capital there, sorry, but afterwards we've got half mv squared again, okay, but we've got to think about how we're going to do this, because we've got two objects now, okay, with both got kinetic energy. So the way we're going to do this is half times 150 times 27 squared. Now you might say, well, look, this has got a negative velocity and this is a positive velocity. Energy is a scalar, so it doesn't matter. The negative value just represents the direction, so we don't need to worry about that. We can just do half times 150 times 27 squared. And then we've also got to add on to that the kinetic energy of the probe itself. So that's half times 350 times 240 squared. Okay, so if you work all of that out, you're going to get 1.01 times 10 to the 7 joules. All right. And that means that there's been a gain in momentum, okay? So, or a gain, sorry, in kinetic energy. So the gain in kinetic energy is just equal to these two subtracted from one another. So 6.4 times 10 to the 6. So that gives us 3.7 times 10 to the 6 joules, okay? So that's the gain in kinetic energy. So you may remember that when we talk about momentum, we say that collisions and explosions are either elastic or inelastic. Usually that's in terms of collisions, that they're either elastic or inelastic. Elastic means that the kinetic energy is conserved. Inelastic means kinetic energy after the collision is less than before. In this instance, we've got an increase in kinetic energy. So how can that be the case? Where is this kinetic energy coming from? Well, if you think about it, there was an explosion, and that explosion converted chemical energy from the explosives into extra kinetic energy of the objects. So this extra kinetic energy has come from the chemical energy of the explosive charge that was used to fire out this capsule. Okay, so that's that one done.